So today in this block, we are in topic 5, block 3, and we're going to be representing integer operations with concrete models and connecting the actions with models to standardized algorithms. We're also going to show that a number and its opposite have a sum of 0, and we're going to be able to add integers using a number line, along with applying real world situations for adding integers. So that's what we're going to focus on today. So the first thing that I want us to do is I want us to think, do we have any friends or relatives or know anyone that lives in a different time zone? I have one friend that lives in a different time zone. Akira, what about you?
Yeah, I have one.
All right, where do they live?
I forgot. I think they moved out of that zone, but I don't remember now.
All right, what are you thinking, Vincent?
I actually have two. One lives in Michigan, the other lives in California.
All right, so are they ahead or behind in time?
I know California is behind. They're behind by 2 hours.
All right. Good job. You're right. You're right. All right. Good. Angel?
Half of my family lives in Alabama.
Okay. Trying to think of Alabama. I think Alabama is probably pretty close to us. Hermione?
And then some other ones live in Pennsylvania.
Hermione, where does yours live?
I live in Ohio.
In Ohio? Okay. And then Rachel, she had her hand up. Rachel, what about you?
She just left.
Uh-oh. All right. So tell me this. If we got a friend that lives in California and we're here in Louisiana and we're waiting for the Fortnite new setup to drop, is it going to drop at the same time in California as it does here?
No.
So you're telling me I can't play with my friend that lives in California when it drops in Louisiana?
Oh, you can.
You can, but you have to play.
Yeah, you can still, because it's still going to drop, all right, at the correct time all over the world, all right? So basically what that means is we're going off of one universal time, and then after that universal time, depending on where you're at in the world, on the globe, you're either going to be earlier or later in time compared to that actual universal area, okay? Which would be in basically the center of the globe. And so what we're going to do is we're going to learn about that here in just a minute. So go ahead, Akira. If you would, Kalia, will you read about Archibald, please?
Archibald Ant has looked at his bank account and decides Greenland and Spain are both too expensive. Instead, he has found a discounted plane ticket to Hawaii where he can stay with relatives. In planning his trip, he has learned that the local time is different in Hawaii than it is in New York City, where he lives. It is also news to Archibald, but you probably know that the whole Earth is divided into different time zones. On this map, each time zone is marked by a different letter. Which zone do you live in?
All right, so looking at this, we got our globe spread out flat, okay? So as we're looking at this, does anybody know where we actually live? Where would we be at?
It's right there, left.
All right, we're going to be on the left somewhere. So are we in this continent, kind of over here?
Yes.
Okay. So if we're looking at the United States, we're kind of like this, right? All right. So looking at that, we're looking at between V and Q. All right. So where are we exactly, though? What's something we could look at that would help us? What state would help us be able to figure out where we're close to? Looking at that little bitty picture and kind of figuring out where the United States is. What's something we could look at? What state? Ooh, I hope.
Texas.
All right, Texas. All right, I kind of can see where Texas would be, but I'm trying to think of somewhere that's like close to the ocean.
Florida.
There we go. So, looking at Florida, you can see is kind of right there. All right, that's kind of the edge of Florida coming out. And are we close to Florida?
Yes.
Pretty close, right? So, if we were looking at us, we're going to be somewhere around that area, right? Somewhere in there. So, if we're looking at that area, what time zone is that? What letter?
S.
We're in S. That's right. We're in S. Now, what I want you to do, if you have access to a computer, which most of us should, I want you to look up what actual time zone Louisiana is in. Some of you might know.
We're in Chicago Central.
All right. I got somebody that says Chicago Central.
Central Standard Time.
All right. Grayson.
Central.
All right. So we are in Central Standard Time. Okay. So based off of that, we're going to use that information to answer a few questions to what would happen if maybe you called somebody that lived in a different time zone. All right. Or what time it is on one side of the world compared to what time it is in another part of the world. All right. So we're going to look at page 2. All right. If you would, Miss Angel S., would you read this, please?
Did you know that integers are used to compare the different time zones? Time zone Z on the map represents the center of the globe. It's marked the time 0. The time in that zone is called Coordinated Universal Time (UTC) or Greenwich Mean Time (GMT). Moving to the right from zone Z adds hours to the UTC, making it later in the day. Moving to the left subtracts the hours from the UTC or makes it earlier in the day. You can actually move so far on the right or the left that you cross the international date line and gain or lose a whole day. Here are a few places you might have heard of and their position on the UTC.
All right. So looking at this, it said that in the center of the globe, we're looking right here. Okay. So since we're looking here, and this is the center, which is UTC, all right, or Coordinated Universal Time. That's like our neutral, all right? So if we move to the right, are we earlier or later in the day?
Earlier?
Early. Later.
Later in the day. Man, the dogs are going crazy there. All right, so later in the day. All right, so that means if we move to the left, it's going to be what? Earlier in the day. Good. So I want you to write that down on your book. Remember, we're on page 145. And so you should have an answer for number 1, which was the question a while ago, saying what time zone do we live in? So you should say Central Standard. And that's going to be right above this, okay? And so that was kind of like a question right before number 1. So it was an opening question. And then number 1, we're going to answer based off of this. All right. So I want y'all to take a look at this. So looking at our universal coordinated time zone, you'll notice that everything on the left is earlier. Everything on the right is later. So we're going to take this and we're going to use this number line to answer the following questions. Okay. So we're going to go to page 3. And we're going to answer this. So if you would, Grayson, would you read this for us, please, sir?
I'm sorry, I wasn't paying attention.
That's
My
all
mom
right.
was asking
I just
me
want you to
questions.
read that.
Okay. With the number line, you can see that when it is 12 p.m.
UTC?
UTC, it is 2 p.m. in Egypt because it is 2 time zones to the right. Also, when it is 12 p.m. UTC, it is 7 a.m. in New York because it's 5 zones to the left. You can calculate the times for any place on Earth by using the time zone map and calculations with integers. When it is 12 p.m. UTC, what time is it in California?
All right. So I want you to take a second and see if you can figure that out. And while you do that, I'm going to talk to our principal.
Mr. Martin, I found it out.
Hello. Hey. I don't. She is actually in the class with Miss Rhonda Long. It's in Mr. Allen's room. So I think it's like
It's 10
room
o'clock.
209. I'm all the way across. I don't know her number. Mr. Allen Williams is, I think. Yes, sir. Okay. Mr. Williams, can you let Miss Rhonda know that Ashanti Brooks needs to come to the office, please, sir? All right, go ahead, Miss Angel, and tell me what you think. Go ahead, Angel B.
10 o'clock a.m.
All right, she said maybe 10 o'clock a.m. I don't know if that's going to work.
Is it 4 a.m.?
All right, because it's normally 12 p.m., and that is right here. So it's 12 p.m., and we said that we want to know what time it is in California, which is way over here. So I want us to count the time zones. So if we count the time zones, it's 1, 2, 3, 4, 5, 6, 7. How many time zones?
8.
Yeah, so it's 8 hours what?
Back. So it'd be 4.
Earlier. Yeah, it's 8 hours earlier. So what does that mean, Grayson?
It'd be 4 a.m.
That's right. Why is it 4 a.m. and not 4 p.m.?
Because 4 p.m. It'll be morning time.
Yeah, it's in the
That's when
morning.
you go back.
All right. How did you know that it was? How did you do that? What did you do to get your answer?
All I did, I just counted back. I went 12, 11, and then so on and so on.
I got you. So the way that I like to do it is I kind of think of time broken into just kind of broken in half with 6 hours. So if I do 12 p.m. and I take away 6 hours, that would be 6 a.m. And so it's only 2 hours earlier than that. So I knew it would be 4 a.m. So that's kind of how I think about it in my
What
head.
I used to do it about time is I used to when I was younger, I used to take this little book that had a clock on it, and I used to move the little clock arms around, and it actually helped me learn. And then when I got older, I learned about I learned it as money.
Okay. You might have to explain that to me later.
I don't know.
All right, here we go. So let's look at this. It says, pretend you live in Colorado and it's 9 p.m. and you decide to call your aunt that lives in Argentina. What is likely to be her reaction? What do you think, Brandon? It says, we live in Colorado. It's 9 p.m. and you're going to call your aunt that lives all the way over here. How many time zones is that, Braden? Satari, can you help him out? How many time zones is that away?
Wouldn't it be 5?
Oh, let's count them. It's going to be pretty close. 1, 2, 3. How many is it?
4.
4 of them. All right. So that means, is it going to be 4 hours earlier or 4 hours later?
Earlier.
All right. Did we go to the right or the left?
Left.
You sure?
I mean, yeah. I'm
All right. We started here at Colorado and we went this way. So is it going to be earlier or later?
Later.
It's going to be later. So Brendan, what time is it going to be?
Five.
All right. Brendan said maybe it's 5. I want to count it. Let's count it. So it was 9. So we're going to count 4 hours past 9. Okay. So just use your hand. All right. So 1 hour would be 10. 2 hours would be 11.
Isn't it 1 a.m.?
Yes. 3 hours would be 12. And 4 hours would be 1 a.m. All right. So it'd be 1 in the morning. So what do you think your aunt's going to act like? Is she going to be happy that you called her?
Probably not because it's too early.
Yeah, she's probably going to be pretty tired or wondering if somebody's hurt because it's so late. All right, so did we answer these questions by counting the spaces on the number line, left and right? Yes or no?
Yeah.
Yeah, we did. Good. All right, so let's look at the next question. All right, so based off of what we just did, we should have been able to answer questions 1, 2, and 3 in our workbook. So that means we're no longer on page 145. Everybody should be turning to the next page, which is 146. So we're going to start with having Mr. Levi read this for us. Go ahead, Levi.
Okay. First, begin with adding integers. Archibald is ready to explore the number line and show you how. Archibald is standing at 0. He's going to demonstrate adding 2 numbers, 6 plus 4.
All right, so what I want you to tell me, Levi, if Archibald's going to model this, which way is he going to be skating and how far is he going to skate?
So he's going to skate to the right, and he's going to be skating 6 units to the right for the first number, and he's going to skate 4 more to get the answer.
Correct. All right, now, so the total distance that he's going to be from where he started is going to be how far?
6.
The total distance?
No, the total would
The
be
total would be 6 and 4 combined, which would be what?
10.
10 units. All right. So distance is the amount that you are away from something, right? All right. So what I want you to think about is when I said how far is he away from where he started? Well, he started where?
0.
He started at 0. So anytime somebody asks you, what is the absolute value? That is the distance that a number is from 0. So whenever we're looking at Archibald, and Archibald's just going everywhere skating because this man wants adventure time, so he's gone. He went 6 units to the right. So if I said, what is the absolute value of 6, you would say what? What would you say? It's silent. Somebody help me. If I said, there you go. Thank you, Tom Marianne. All right. And so we already said that Archibald's going to go 6 units to the right and then another 4 units to the right and end at 10, which is correct. Okay. So let's look at what would happen if Archibald was to model this number sentence. Kalia, read this number sentence and tell me what would happen.
First, begin with adding. Oh, how can Archibald model -4 plus or divided? Is that plus or divided?
Plus.
Plus -2.
You need me to make it bigger? That better?
Yes, sir.
All right. So what's going to happen?
Wouldn't we add -4 plus, will we start at 0?
He is at 0. Now, is Archibald going to go to the right or go to the left?
Wouldn't he go like 3 to the left?
Would he go 3 or would he go 4?
4. He would go 4.
Yeah, he would go 4 units to the left. Good. And then it says we're going to add -2. So would he go 2 units to the left or 2 units to the right?
Left.
Correct. He's going to go to the left. Ooh, I had a lot of people that were confused. If we add a negative goes to the left. Okay? Negatives are on the left side of the number line. Positives are on the what?
Right.
Right. All right. So I want you to write that down on your number lines. All right. So from here to here.
They were like we added 2, like +2.
All right. But it's a negative, right? And so if we add a negative, we're going to the left. If we add a positive, then we're going to the right. I think we're still confused on that. Somebody restate what I just said. If we add a negative, what's going to happen?
Add a negative.
If you add a negative, you go to the left. But if you add a positive, then you go to the right.
Correct. All right, Khalil, can you restate what was said?
If you're adding a negative, you go to the left, and if you're adding a positive, you go to the right.
Perfect. All right, Grayson, does that make sense? Yes or no?
Yes.
All right, cool. Number 5. All right, so looking at this, Archibald's moving all around. All right, so he's going just skating wild. He went 6 units to the left, and then he went 6 units to the right. So that means that -6 and 6 are what of each other?
Canceling each other out.
They are canceling each other out. So, Alora, that means they're what to each other? It's a word that starts with an O.
Opposites.
Yeah, they're opposites. And we know that opposites, when added together, have a sum of what?
0.
0. That's correct. So remember that opposites have a sum of 0. And anytime we add opposites to each other, they are called the additive inverse of each other. So anytime you hear the word opposite, I want you to think additive inverse. So opposites are also known as what?
Additive inverse.
Great job, Tamarian.
Inverse.
Correct. Good job.
Wait, how you say it?
Additive inverse. Additive inverse. See it?
Additive inverse.
Yeah, right there.
I was saying added inverse.
Oh, okay. But do you see how it says it? Additive?
Yeah, now I do.
All right, cool. We got it now. Good job. All right, so we're going to go to our next question, which is on part 6. And you'll notice it says, what is 6 plus -8? So looking at that, Hagen, what would Archibald do here?
He would go to the right 6 times. And
Correct.
then he would go to the left 8 times, I guess.
You're right. And so whenever he does that, where's he going to end up at?
He's gonna end up at, I think, -2.
Perfect job, man. Great job. Great job. Does anybody have a question about that? Grayson has a question, I think, or Grayson might have an answer. Grayson, what you got, buddy?
Oh, I had the answer.
I got you. Let's look at number 7. Do this one for us, Grayson.
You have to go 7 to the left and 8 to the right. So wouldn't it be +1?
Correct. Great job. Anybody have a question why it's doing that? Why does he go to the left for -7?
Negative
Because-
goes to the left.
Yeah, negative we go to the left. Why does he go to the right for 8?
Because positive goes to the right.
Perfect. All right. If you would you please read this for us, Khalees?
You and Archibald have modeled the sums of integers using the number line. Now can you make a generalization about adding integers? What happens to the sum when you add a positive integer? What happens to the sum when you add a negative?
All right. So what happens to the sum when we add a positive, Khalees? Is it going to increase in value or decrease in value?
Increase.
Okay. So what would happen if we were to add a negative integer?
Decrease.
All right. Does anybody have a question about that? That's a perfect time to ask if you do. So somebody restate what Khalees just said.
If it's a negative, it goes to the left. If it's a positive, it goes to the right.
All right. I thought she said something different. It says, what happens to the sum when you add a positive integer?
It becomes a positive, or it zeroes out, because if you make it a negative and then you add a positive to it, it would just zero out.
If they were opposites, yes. But what if they're not opposites? Or not even thinking about that. If it was a negative number and we added its opposite to it, what's it doing to the value from the starting point? Is it increasing or decreasing? Yeah, it's increasing. What happens to the sum whenever we add a negative?
It'll decrease.
It decreases. It reduces in size. It gets smaller. Okay? All right. So with this on page 4, we should have been able to answer question 4 in our workbook. If you do not have question 4 answered, you need to answer it in your workbook now. All right, looking at page 5, all right, this looks a little odd, okay? The reason that it looks a little odd is because it is different than what is in your workbook, okay? So what I want you to do, I want you to work in your workbook. I believe this is on page 148 in your workbook. Work this, then we'll look at the computer. So everybody at this moment needs to be in what?
Page 185.
No, page 148.
Yeah, my bad.
Yeah, you're good. All right, so page 148, and I want you working this in your workbook. The reason I'm telling you to do this is because your workbook is different than the computer. They're not going to be the same answers. So everybody's going to work in their workbook. I'm going to give you 3 minutes. It's 1:32 right now. So at 1:35, we're going to review over this, how it looks in the computer, and then you'll be able to correct yours in your notebook or your workbook if needed. Okay, so remember that your answers in your workbook are not the same as what's on the computer. All right, so I'm going to give you that time to do that now. All right, here we go. Let's take a look at this. So once again, remember this is going to be a little bit different than what's in our book, but we're still going to be able to do it the same way. All right, so looking at this first one, you should be able to tell that we're starting at 0. Okay, and so this is going to be basically exactly opposite from what you have in your workbook. So that means that this and the one below it are going to swap places in your workbook. All right, so we're starting at 0, and then from 0 we're going all the way to this number right here. And so what is that number?
5.
Yeah, it's number 5. So we would put a 5 here. All right. And then from 5, we're going to the left. So is that going to be negative or positive?
Negative.
Negative. Good job. And so if we're going to count this, okay, so let's count these together. We're going to count the camel humps all the way to where it ends with our answer, okay? So let's do that. So that's 1. We might have to go back to kindergarten. Let's try it again. That's 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that's 9 units to the left. So is that positive or negative 9?
Negative 9.
Negative 9. All right. And so our answer would be what? What would we put for our number sentence?
5 equals negative 4.
Great job. 5 plus negative 9 equals negative 4. All right, so we're going to do the same thing to these other ones, okay? So looking at this one, we're starting at 0, and we're going all the way to this number here. What is that number?
9.
We went to the right, so is it positive or negative?
Positive.
Okay.
Positive.
All right, now we're going from 9 all the way to our sum or our answer. So we're going to count together all the way to 0. So let's do that. 1,
1,
2, 3, 4, 5, 6, 7, 8, 9. Okay, does everybody see that? Now we went to the left, so is that going to be positive or negative?
negative.
All right, so that would be our negative 9. And we know that 9 and negative 9 are what of each other?
Opposite.
Opposites.
Correct.
And opposites are also known as,
0.
well, it is going to be 0, but opposites are also known as a special word that I told y'all a while ago in class. Hopefully somebody's got it. Correct. Great job. Additive inverses. Good job. Y'all getting it. All right, so let's look at the next one. So looking at this next one, once again, it shows us starting at 0. I know it looks funny, but we're starting at 0 right here. And we are going to the left all the way to here. What is that number?
9.
Negative 9. So we're going to put that there. And then from negative 9, we go all the way to negative 3. So we're going to count, okay? So are we going to the right or going to the left?
The right.
The right. So is it going to be positive or negative?
Positive.
Positive, because we're going to the right.
What?
All right, the answer will be negative, but C is going to be positive. So we got 1, 2,
2,
3,
3,
4,
4,
5,
5,
6. All right, so, and is that positive 6 or negative 6?
positive.
Positive 6, because we went to the right from negative 9. So that means that our number sentence for H is going to be what?
9 plus 6.
Negative 9 plus 3 equals negative 3.
All right, somebody raise your hand, and then I'm going to let you go. All right, Hermione.
9, negative 9 plus 3 equals
Is it negative 9 plus 3 or plus 6?
plus 6.
Yeah. Equals what?
3.
Negative 9 plus
6 equals negative 3.
Yes. Great. I think that was the computer talking to me, but she did a good job. All right. We got it going on. Kalia, do you have a question, or were you going to say that was how to do it?
Yeah, I was going to say the number sentence.
Perfect. All right. Does anybody have a question? This is the time to ask. All right. Well, I guess we're going to keep moving. All right. I'm going to give you a little time to correct your book just in case it was wrong. Remember that our book is different than what was on here, but it's exactly the same style. Okay.
The only thing different about the computer and the book is we don't have like the list of them. Everything else is just right.
You think so? I thought these numbers were swapped.
Actually, it doesn't give you the list, but I think it's right. Like the little boxes and stuff.
I thought in your workbook, like when I looked at the workbook a while ago, it said that it basically had this 5 down here, starting from 0 and going to 5, and then the -9 was on top. Look at it in your workbook real close.
Yeah.
All right, here we go. We're going to keep moving. All right, so we're going to take a closer look at this one. All right, this was the one that was in your workbook. All right, so let's go with someone we haven't heard from today. Let's go with Miss Natalia. Miss Natalia, I want you to read this for us and explain what's going on.
Take a closer look at this model. How long is the arrow that represents the integer 5? So you want me to explain it?
Yeah, how long's that arrow? How many
To
units?
the right,
Yeah, from 0. How far is that distance?
5.
Yeah, it's 5 units. Perfect. All right, go to the next one.
You want me to read that?
Yep.
In this case, the length of the arrow is the same as the integer it represents. How long is the arrow that represents 9?
Is it 9 or -9? It says how long is the arrow that represents?
-9.
All right, so how many units long is the arrow that represents -9?
-4.
All right, so you think that the distance from here all the way to here is -4 units?
Oh, no.
No. All right, so how long is that? How many units?
Well, you want me to count like
Yeah.
9?
Yeah, it's 9 units. That's right. All right, so it says in this case, the length of the arrow is different from the integer it represents. So just a second ago, Natalia said it represents -4. All right, well, the reason that it's representing -4 is because it's going all the way from 5 to -4. All right, and that is because we were doing some addition. So also, based off of that, we also know that we can't have a negative distance. Okay, so whenever we were saying that -9 is 9 units long, well, you can't have negative distance. Okay, there is no way possible to make negative distance. You can only have positive distance. And so, what I mean by that is, for instance, if I'm asking you the space that's between my hands, well, that's a positive space. Well, if my hands are already closed and I'm at 0, there is no way to push my hands inside of each other. Like, so if you take your hands like this, there are no way to get negative space because that is as close as they can get. You're not going to be able to make your arm disappear into your other arm. If you do, you're going to be messed up for the rest of your life. So there's nothing that is negative space. All right. Space is always going to be a positive amount. And that's why distance and absolute value is always positive. Okay. So it says, what term do we use to mean the distance that something is from 0, no matter what direction it's in? What is the term that we use to represent the distance from 0? We talked about it earlier.
Something called
Not the additive inverse. Has something to do with value. You might have to go back through your notes. Levi, Grayson, Kalia, Rachel, somebody, Sophia, Vincent. What is the distance that a number is from 0? What's that called?
Integer.
The absolute
Inverse.
value. The absolute value. Thank you. Thank you. So the absolute value is the distance that a number is from 0. Grayson, restate what I said.
The absolute value is the distance from the number 0.
Correct. Tamarian, restate what Grayson said.
The absolute value is the distance between 0. Or I messed up.
What's between 0?
The what between 0?
I don't know. That's what I'm asking you. Somebody help him out.
The distance.
The distance that what is from 0? Help him out. The absolute value.
Absolute value.
Go ahead, Satari.
The absolute value
Is the distance
From 0.
I disagree. Grayson's looking at me crazy. All right. The absolute value is the distance that a number is from 0. Sophia, restate that.
The absolute value is the amount
Of distance
of
But-
distance between 0
and a
what
and a
and a. Where'd and a come from?
well, you kind of went
And a
off.
number.
And a number. Great job. All right. Hopefully Mr. Williams' class got that going on. I'm not getting many thumbs up or anything. Hopefully we got it rolling. So Mr. Williams' class, go ahead, man. Tell them, get them to restate, if you don't mind, that the absolute value is the number or is the distance that a number is from 0. The absolute value is the distance that a number is from 0. All right, let's take a look at number 7. All right. All right, here we go. So, looking at number 7. Go ahead and read this for us, please, Tamarian.
Which one, the blue or both?
Blue.
Start with the integer
Integer.
addition problem. The what?
Integer.
The integer addition problem. 6 plus 4 equal 10. How are the values in the number sentence related to the distance on the number line?
All right, so looking at these, what we need to see is if we started at 6 and we end at 10, what operation is being performed to 6? Addition.
You're adding.
And so how many units are there between 6 and 10?
4.
4 units. And are they 4 units to the right of 6 or 4 units to the left?
The right.
Correct. All right. So we know that if we're on the right side or we're going to the right of the starting number, that is a positive direction. If we went to the left, that would be what type of direction? Negative. Good. So look at this one. It says we have -4 plus -2 equals -6. So if our starting point is -4 and we're going to add -2, are we going in a positive or negative direction?
A positive.
If we add -2,
If you add -2,
A negative.
you're going to the right because you're adding.
all right, we are adding, but 2, is it positive or negative?
A negative.
Negative. And anytime we have a negative number, we're going to the
Left.
left. All right. All right. So looking at this, we're going to start at -4. We're going to go 2 units to the left to get to -6, but it's in what direction?
Left.
On the left, or a negative direction. And we know that -4 is how many units from -6?
2.
2. Good.
So
All right. So this question right here is a pretty good question, and it can get kind of confusing. It says, what are the locations of 2 points that are a distance of 8 units from 6? What are the locations of 2 points that are a distance of 8 units from 6?
One is -2,
Okay.
and one would be 14.
How'd you get those, Grayson?
I counted backwards 8 times, and I counted forwards 8 times.
Perfect. All right. So he counted 8 times all the way to -2. And then he said he counted on the positive side or forward 1, 2, 3, 4, 5, 6, 7, 8 times and got to positive 14. Does everybody see how he did that? Give me a thumbs up if you got it. All right, we're looking pretty good. So we're going to check this answer. And so it wants us to create a number sentence based off of what Grayson did. So Asia, can you create me one of those number sentences, either the one that gives us -2 or the one that gives us 14?
Sir?
Will you create a number sentence for us based off of this information? We started at 6 and then we added a number to get to -2. One of them we went to, so to get to -2, we went to the left. How many spaces?
Six.
Look on that screen.
Oh, 8.
Yeah, we went 8 units to which direction? The left or the right? From 6 to get to -2.
Left.
Yeah, we went to the left. So is that a +8 or a -8?
Negative.
Correct. And so since we got -8, 6 plus -8 gave us our answer, which was negative what?
14.
No way.
-2.
It was -2. Correct. All right. So Satari, can you give us our number sentence for the positive side? What was added to 6 to get 14?
8.
Yeah, 8. Because 6 plus 8 is what?
Positive 14.
Perfect. Perfect job. All right, so in closing to this, can somebody give me an example of a subtraction problem where the difference is smaller than the original number? I'm looking for a problem where the difference is smaller than the original number. Remember that a difference is the answer to a subtraction problem.
You're subtracting a negative to the starting number.
Don't make it hard. Think about it. I'm wanting you to give me a number sentence that's a subtraction problem where the answer is smaller than the original number.
0 plus -4 equals -4.
Okay, that works. All right. Now, can you give me an example where a subtraction problem gives you a difference that is larger than the original?
8 minus 4 equals 4.
All right. Is 4 larger than 8? No. So I want to answer to the subtraction problem that is bigger. So remember the rules. Anytime we subtract a negative, that is the same as adding its what?
0 point. Right?
It's opposite.
Opposite.
So subtracting a negative is the same as adding its opposite. So when I say, can you give me an example of a subtraction problem where the difference is larger than the original number? Let's say we started with 1. If I did 1 minus -3, that's really the same as saying 1 plus 3. What is 1 plus 3? All right, so
4.
somebody give me one that would work.
You can do 0. Actually, I'm gonna list.
Go, Grayson, get it done. Let's go.
Okay, 0 minus negative 4 equals 4.
Great job. All right. And to wrap this up, if I wanted you to give me a subtraction problem where the difference is 0, I need two numbers that are what of each other?
Opposite of each other.
Opposites. And opposites are also known as what?
Additive inverse.
Woo! Good job. All right, my boys and girls, we have an assignment on My Agile Mind. Y'all did a fabulous job in class today. The assignment that we have in Agile Mind is right here. You are going to be clicking on assignment in My Agile Mind. We're going to be working on pages 6 through 10. Miss Chumley's class, y'all have an assignment put in My Agile Mind. Go ahead and get on that real quick, and I will see y'all next time.
See you.
All right, y'all have a good day.
Bye.
You too. You too.